Now lines of flux demonstrators and a simple motor. How cool is that? Yeah, we're talking about starter systems. Matter of fact, breakdown of electrical systems. When it comes to a starter motor, it's all about the lines of flux. What do I mean by that? Well, check out this wire. This has lines of flux. If I put power to it, it's going to want to kick out of this magnet either one way or the other, depending on the polarities and how I put it together. But if I hit this right here with power, bam, there it goes. It stays out of there. It will not. Matter of fact, it knocked it right off, which is pretty cool. It's not going to stay in that magnetic field. That's how a starter works. A simple motor, well, it's got a commutator, and then it's got these windings on here. Watch this. When I put power to this, it's going to want to turn, get it started, and there it goes. No interaction, just the lines of flux, pushing, pulling, pushing, pulling. North pole, south pole, north pole, south pole. That's how a starter works. This is actually a starter armature. This is the commutator, and then these are the lines. Instead of just having two, it has a bunch of them. So it's continuously pushing, pulling, pushing, pulling, pushing, pulling when you turn the key. Now a couple different types of starters. You can see this one right here. This is actually a field coil starter. It's got all the big magnets in there, and that's what's going to help push, pull, push, pull, push, pull as we go through there. Now if you look at this animation right there, you can actually see it. What's happening is it's cutting that field, it's pushing it, and then it cuts it the other way and it pulls it. So the north and the south, and then the wires on the lines of flux are acting around in a circle. Now this one here, this is the field coil, but if you come over here, this is actually a permanent magnet starter. Now it's a lot smaller. It's going to do the job just as good, and it's going to do it with a lot of less amps because we're not dealing with any of these field coils. How does that work? Well, it's real cool. They're called gear reduction. And I can pull it apart and show you right here. This is actually the planet gears, these little guys here, the ring gears on the outside, and then the sun gear goes in the middle. Well, what's happening with that? Well, if I put it together, and you guys keep your eye on the blue line here, if you watch the blue line and this pinion at the same time. So I'm going to turn this is the armature and the pinion. So as I turn that, you see the armature go around once, twice, and 3 times, and that pinion only made it around about once. So you're getting 3 to 1 or a little more gear reduction, which is helping you turn that motor over without a lot of amperage. Now, amperage, what's that all about? Well, we need to look at some couple of schematics. Schematics are always the first place to start when you have a starter issue. Pretty simple to follow. This is a basic one here. You can see I'm starting here with run. I go through here. If you got a clutch switch, if it's a clutch, you have to push it in to get power down to the solenoid. Now, what's a solenoid? It converts high amps circuit. It uses the high amp circuit by using a low amp circuit to control it. So if the low amps right here, you turn your key, you're actually pulling in a winding, and when you pull in a winding, you'll power up that starter motor, which is high amp circuit over here. So my battery is the high amp circuit, and my key is the low amp circuit. And I'll show you that in a second. But if you go to this one here, now, this looks a lot more complex. Don't worry, don't get scared. It's still the same thing. You got 2 wires going to your starter. You got an actual start wire and a bat wire. The only difference is, yes, we're throwing the PCM, the powertrain control module, maybe a body control module, but we're throwing a lot in the mix, which we call enable criteria. It needs to meet stuff like car needs to be in park or car needs to be in neutral. Anti-theft, all that stuff has to be in place before it's going to run that starter, but don't worry, it does it the same way. Matter of fact, I can show it to you in action. This is pretty cool. We got the basic starter board set up right here, so it's really, really simple. If I come over and I just go to volts, really all you want is voltage at 2 places down there, and then you know your starter's going to run. So I'm going to go to the negative, and then I'm going to go to the bat terminal. Once I do that, you can see I got 12.6 volts. I got voltage there. I need it in that place. Now the second place I have to have it is called the start terminal. That's this guy right over here on this side. So I clip him to the start terminal, and what's going to happen is I don't have voltage there. Well, I'm not supposed to until I turn the key to start. So once I go to start, bam, I got voltage there. The starter obviously runs. If I don't, trace it back. Just find out where did the power stop. Now you come over to this guy here. Well, here's my high-tech board. Same thing. I'm just going to turn the key, and when I turn the key, the computer, though, is going to meet the enable criteria and then turn the starter over. So we're going through an engine control module, maybe a body control module. We're getting all that enable criteria and a couple more relays. But the bottom line is, hey, I got to have 12 volts at that bat, and I got to have 12 volts at that start. Now, it doesn't matter if it's old school or if it's new school. understanding how a starter works will make it easy to diagnose one. I'm John Gardner. Thanks for watching.